This is Mr. Beck Does Your Homework. This is AP Physics Homework 3.1 about balanced forces. With balanced forces, we know that if the object is at rest or moving at a constant velocity, that all the forces must be balanced. That means that all the forces up have to equal all the forces down, and all the forces to the right must equal all the forces to the left. So that would either keep it at rest or moving at a constant velocity. If I have any forces at an angle, I have to split them into their horizontal and vertical components. So in this case, a woman pushes a 22-kilogram lawnmower, there it is, at a steady speed. Steady speed is my hint that this is something at equilibrium. You should always look at steady speed or constant velocity, and that should make you happy because you say, great, all the forces are balanced, no acceleration involved. She exerts a 160 Newton force in a direction 27 degrees below the horizontal. So she's pushing down, and that angle is 27 degrees. Acceleration of gravity is 9.8 meters per second squared. Find the magnitude of the vertical force the lawnmower exerts on the lawn. Well, if the lawnmower is pushing down on the lawn, then the lawn will be pushing back with a normal force. So what I'm really looking for is a normal force in this case. So let's look at a free body diagram. What do I have? I have gravity straight down. I have a push force, which I like to start all of my arrows here. So here is my push force, F push. I have a normal force this way, force normal. And if I'm pushing at a steady speed, I guess I must have some friction this way. So now I know that all my upward forces equal all my downward forces, and all my leftward forces equal all my rightward forces. Well, this is up, this is down, this is right, but what's this one? Since I'm coming down at an angle, that force at an angle is made up of a vertical component that goes this way, so I'm going to call that my force in my y direction, and a horizontal component that goes this way. That's my force in the x direction. So I've got an angle of 27 degrees right here, and I can slide this y over here and get a vertical component here, and that will give me my triangle. So with that triangle, I know that the y is the opposite, the x is the adjacent. But notice y is going to be pointing down. I'm not going to write it as negative, but I know that since it's pointing down, I can take care of that in my free body diagram. So this is my true free body diagram. Let's see what I get for values here. I know that this is 160 newtons. So my y is going to be 160 newtons times the sine of the angle 27 degrees. I know that my force in the x direction is going to be 160 newtons times the cosine of 27 degrees. So now I've got a new, I don't want to mess this one up, let's draw a new one. So now new, I've got force of friction this way. I've got my force normal this way. I've got my force of gravity this way. But now I've split this one into one pointing down, so down I've also got my force y. And then this force x is pointing this direction, so now I've got a force x over here. So I know that my force x must be equal to my force of friction, because that's my left equals right. And now I've got my up and down. Force normal is pushing up. That's what I'm looking for. This is the vertical force the lawnmower exerts on the lawn, because that is equal to y plus gravity. So I need my force y plus my force gravity equals my force normal. So I'm looking for my y and my gravity. My y is right here, 160 sine 27. So that's my force y. What's my force of gravity on a 22 kilogram block or 22 kilogram lawnmower? Well, clearly my force of gravity is going to be the mass of the object times the acceleration of gravity. It's going to be my 22 kilograms times my acceleration of 9.8. Notice I've left out my negative in this case. I leave it out because I've been taking care of my pluses and minuses with arrows, so I know that my y is down, my gravity is also down, and I don't want to get messed up by having negatives and positives added together. So really I want magnitudes here. So I got my y here and my gravity here. I add those together and I will get my normal force. And that is the force I'm looking for.